Hi, I'm Cole Berger,
Abdallah Duraz.
And I'm Will King.
and we are Team Pong Physics, team number 4, and we are here to present our design phase 1. So in our design phase 1, the first step we had to accomplish was our project planning phase. And in here, we all had to come up with individual ideas for our 3 stations of our BRG. And in these 3 initial concepts from each of us, we found that our ideas all fell into 3 main physics categories, those being minimum force, projectile motion, and rotational kinematics. And then once we finalized our ideas down further, we found out that we would use a fan to project the ping pong ball up through a tube and into the next station, and then go down a ramp and launch into the next station, and then finally go through a loop and end our BRG. And then through this, we found that all of our ideas were reiterations of previously existing physics demonstrations, and we would just put a slight spin on it since it will all be connected together. Then here we also have our technological trajectory, which shows our maintenance costs over time for our different stations. And here you can see that our stations that require electricity will increase in cost over time because they will have electrical components that need to be replaced and also batteries that need to be replaced. And then continuing on, we have our mission statement, which we had to create to show what our project is and what it is doing. And in here, we found our target markets, those being the high school STEM teachers and the students of those teachers. And then through that market, we were able to identify stakeholders, those being those high school systems and also the VTEPS Incorporated, which is our mother company. And then also in our mission statement, we had to make some assumptions about the user and what our project is going to accomplish. So obviously we wanted to reinforce physics principles, and also we assume that our user has a basic understanding of those physics concepts and also how to assemble our product.
Okay, so now we're going to talk about the project management aspect of design phase 1. So we developed a Gantt chart as seen here, and that's going to give us an overview of the tasks that need to be completed in design phases 1, 2, and 3. Of these 3 phases, design phase 3 is the least developed because we don't know entirely all the tasks that will need to be completed once we finish design phase 2. Design phase 1 is the most developed as we've completed most of the tasks. These include mainly project planning, concept development, so we were able to develop the initial stations that we needed to do. We also included some initial economic analysis so that we have an idea of what the product will cost. We're going to be moving into design phase 2 now, as seen in the middle. This is going to focus more on developing CAD models as well as physical mock-ups of the stations so that we have a better idea of how we want to manufacture the product.
So in order to determine our product specifications, we had to create a hypothetical high school physics teacher. And we determined that the high school physics teacher would have the following needs. He would need the product to be low cost, durable, educational, and challenging. And so the product will be costing less than $150. So it could be affordable to the high school physics teacher that we're marketing the product towards. It will also include spare parts so that the product will be durable and hopefully last up to 4 years. Moreover, we're going to include sample problems for the students to attempt. We want the sample problems to be challenging, however not demotivating, and so we will include an answer key with the sample problem so that the students could learn from the mistakes. So on top of the hypothetical physics teacher, we interviewed 6 different customers about 6 different physics themed toys, and we analyzed the recurrent likes and dislikes of these products, and we ranked different BRG course needs in this table, ranked them from 1 to 5, 5 being the most fundamental and 1 being the least fundamental. And the product has to be engaging and challenging since we're marketing it towards high school students and we want them to learn from the sample problems that they do about the BRG course.
So once we had our customer needs, we were able to come up with some target specifications to compare those needs against. And that is shown in this table here, and was highlighted in yellow are most technically important specifications, those being the number of separate components and whether those components are adjustable, and that allows the user to have the versatility they need in the product. So we want to keep those very important when we're designing our product. And then highlighted in red are most technically difficult product specifications, And those are the price. We want to keep our product high in demand while also having competitive pricing in the market. And then whether our product has assembly and how difficult that assembly is. And then we compared our product to other similar physics products that are already out on the market. Those being, we have a loop, a projectile launcher, and an inclined plane demonstration. Here you can see the loop is pretty small in scale, maybe has 1 to 2 uses, and that all contributes to its very low price of $26.25. And then we have the projectile launcher, which is made of a sturdy metal, has several adjustable components to adjust launch speed and launch angle, and that attributes to its relatively normal size pricing. And then finally, we have an inclined plane with multiple sensors, adjustable components, and a lot of unique aspects to it, which makes the price relatively high.
Okay, so next we're going to talk about the economics of the product. The first thing that we did as a team was we generated a bill of materials using different components of the BRG. The highest cost that we found would be the Arduino board and accessories, coming in at approximately $35, as seen here on the chart. The final cost that we found would be approximately $132, and that was using estimation of the different product costs. Using that bill of materials as well as fixed costs set by VTEPs at $11,250, we were able to generate functions for profit, revenue, and costs. Using the functions that we generated, we were able to graph them on a cost versus quantity produced curve. We were able to use this curve to calculate the low and high break-even points as well as the maximum profit. The low break-even point is 258 BRGs, while the high break-even point is 4,362 BRGs. The maximum profit is $42,111, and that's when 2,310 BRGs are being produced. That's approximately 6 BRGs per day, so that is definitely reasonable. And at that point, the product cost would be $155, so that's pretty close to what we had initially hoped for in our product specifications.
After the product research that was done during DP1, going forward we will be creating CAD models for all 3 stations, and we'll also be prototyping them in order to determine whether any adjustments need to be made for the product.